So
We
is
talked
there?
about the turning effect of forces.
Yes, sir.
Like you can see many examples around you. Like you can see when you open a door, you just push the door, but it rotates, right?
Yes,
Yes,
sir.
sir.
Yes. So that is called the turning effect of force because the door turns. And after that, there is a term. There is a new term called moment. What is moment?
So I don't.
Moment of force. This is called moment
Moment.
of
Force.
force, which is you can say is force multiplied by the perpendicular distance from the pivot. Now, what is this pivot? See, if you want to understand the pivot, you can say like this is the door. You can see this is the door. So this point on which the door is attached to the wall, that will be called the pivot. Okay.
Yes,
Yes,
sir.
sir.
Yes. Got it. So if you apply the force here, okay, tell me one thing. You want to open the door, okay?
Yes,
There
sir.
are two handles. One handle is here at point K and one handle is here at point L. Which handle you can easily open the door? Which by pulling which handle you can easily open the door? Handle L or handle K?
So
Um,
says B.
Yeah, like this handle, right?
Yes, sir.
Because it is away from the door. The more the point is away from the pivot, more force it will generate. Okay.
Yes,
yes,
sir.
sir.
More the distance, more is the moment of force. Got it?
Yes, sir.
Yes. And after that, what we have this this is called seesaw, right?
Yes,
Yes,
sir.
sir.
Yes, you must have played on this, right?
Yes, sir.
So I've never.
Yes. So what happens when force on one side becomes heavier, the the tilt is on that side, and this is the pivot. This is called pivot. Okay.
Yes,
Yes,
sir.
sir.
But do you see one thing? Do you see in this image B, the the seesaw is in balance, but there is more weight on the left side, right side, and less weight on the left side. Why is it in balance?
Um.
So, so because the
So the
metal,
length,
the metal is different.
the length.
The land.
Because the distance. Because if you sit closer, your force will be less. If you sit away, your force will be more. Okay.
Yes, sir.
Yeah, this is pivot. If the point it goes farther away, its force increases. But if it's come nearer to the pivot, its force decreases. Okay.
Yes, sir.
Yes, sir.
Yes. Yeah. So this is example one. Uh,
Mm.
Look at the figure 5.2. Where is figure 5.2? 5.2 figure is here. Person A pushes the door with force 200 Newton at a distance 20 centimeter from the hinge. Person B opens the door by pulling the door handle which is 80 centimeter from the hinge. What is the minimum pulling force that person B must use to open the door? You know, this is the pivot. Okay, the image is already here. This is the pivot, or you can say this is the hinge where the door is attached to the wall. Now, a person is pushing the door with a force of 200 Newton and he is very closer to the door. But if you want to pull it, because you are pulling it from a distance, you have to apply less force to pull it. Got it? Yeah.
Yes,
Yes, sir.
sir.
So this is the calculation that you have to do. You know, how much force are you applying on it? You are applying 200, right?
Yes, sir.
Yeah. And at what distance? You will say on the distance 20, right? So what will be the moment of force? The moment of force is force applied multiplied the distance, which is 20. and this must be equal to this one. So the distance is 80, right?
Yes,
Yes,
And
sir.
sir.
how much force we have to apply? Let's call it F. So when you simplify this, you will get 400, 4,080 divided by 4,000. This becomes 500 and then 50 Newton. That means if you apply a 50 Newton force here on the door, you can easily open the door. Okay. He is applying 200 Newton, but he is close to the door. So what is the calculation that we are doing here? The calculation that we are doing here is we are calculating the moment of force in the two cases, one in this case and one in this case. And if this moment of force becomes more than this one, then the door will open. How much moment of force is here? You will say, sir, the force is 200 Newton and at 20 centimeters. So the total becomes 200 into 20. Now the force that we need to apply must be greater than this or equal to this. So we don't know the force. Let's call it F. But the distance is 80. This is another moment of force. They should be equal. So when you solve, you get F equal to 50 Newton. Got it?
Yes, sir.
Yeah. And after that, what is center of gravity? Can you read this?
Sir.
Yes, sir. Okay. Try balancing a ruler on your finger, as shown in figure 5.7. When the ruler is balanced, the anti-clockwise moment of equal to the clockwise moment is equal to the clockwise moment, but there are no downward forces acting in the situations.
Other than the weight of the rule itself. We know that the weight of the ruler is due to the pull of the earth gravity or the mass of the ruler. The mass of the ruler is equally spread throughout its length. It is not it is not therefore spring freezing to find that the ruler balance at the central point. We say that the center of gravity of the ruler is at the is at this point. The weight force of the ruler acts through the center of gravity. It is the point where the whole of the weight of the ruler appears to act. If we support the ruler at this point, there is no third moment in any direction about the point, and balance the center of gravity is something called the center of mass.
Yeah. You know, if you have to balance a ruler on your finger, you will balance it only when the two sides weight are equal, right?
Yes,
Yes,
sir.
sir.
Yes. So this point where the two side weights become equal, it is called center of gravity or center of mass. Okay.
Okay, sir.
Yes. Okay. And now what we have? Yeah. See, what do we have? Object not pivoted at center of gravity. You can see this is at center of gravity, right?
Yes,
Yes,
sir.
sir.
Yes. You know what are they doing? What is pivot? Pivot is the point where it is fixed. Either it can move downward or like upward like this. Okay, this is called pivot. So you know what? If the pivot point is not at center of gravity, it will fall in this direction, right?
Yes,
Yes,
sir.
sir.
But if the pivot point will come here, now the weight is on this side, on the left side, so it will move counterclockwise. Here it is moving clockwise. Here it will move counterclockwise, right?
Yes, sir.
Yes. Because more the weight on that side, it will bend in that side, right?
Yes,
Yes.
sir.
Yeah. And now forces on a beam. What is a beam? Can you read this?
Figure 5.13a shows a boy standing on a beam across a stream. The beam is not moving, so the upward and downward forces must be balanced as the boy is standing in the middle of the beam. As the boy is standing in the middle of the beam, the upward force on the end of the beam are the same as each other. The forces are shown in figure 5.13b to keep the thing simple. we are ignoring the weight of the beam. If he moves to the end, if he moves to one end of the beam, as shown in figure 5.30c, then the upward force will be all the upward force will all be at the end of the beam as he moves along the beam. The upward force at the end of the beam changes in figure 5.13d. He is one quarter he is one quarter along of the beam. The upward force of the support nearest to him is the third quarter of his height, and the upward force on the end of further away from him is only one quarter of his height.
Understood?
Yes, sir.
Yes, sir.
Yeah. See, what are they saying? If you stand in middle, then it will be in balance, right?
Yes,
Yes,
sir.
sir.
See here. Yeah. What is happening? Can you explain what do you see in figure A?
So in figure 8, he's standing on a beam across a stream.
Yeah. And what about B?
So it's like he's standing in the middle.
So his
And
weight is getting
what
distributed both
what
sides.
is mm, yes, sir.
His weight is getting distributed on both sides, right? But if he will
Yes, sir.
come on one corner, his total weight will come in that corner. But if he is moving slighter away, more weight on the side which he is nearer to, right?
Yes,
Yes,
sir.
sir.
Yeah, where the load is applied. And after that, can you answer these questions? Question A,
Yes,
question
sir.
B. Can you answer these four questions?
Yes, sir.
Which of the following quantities is not weight of one area, of course?
That.
Which of the following quantities is not a vector quantity? What is a vector quantity? Do you know?
No,
No,
sir.
sir.
Okay, there are two type of quantities. One is called vector quantity and the other one is called a scalar quantity. Okay.
Yes,
Yes, sir.
sir.
So the quantities for which you need to know the direction also. You need to know the direction also, or there can be a plus or minus sign. They become vector quantities. The quantities for which you do not need to know direction, no need of direction, they are scalar quantities. So they are asking which of the following is not a vector quantity. Out of these, which of
False.
the following? No, area is
False.
not a vector quantity. For area, you don't
Okay.
need direction. See, force is directional because either force is in this direction or force is in this direction or force requires direction. Displacement requires direction. Velocity requires direction. Which of the following is not a scalar quantity? Which one is not a scalar? Which one is vector? Acceleration is a vector quantity. Okay.
Yes,
Yes, sir.
sir.
I will write all the scalar and vector quantities. Wait. See, all the vector quantities I'll write here. Like displacement is vector. Okay.
Yes, sir.
And after displacement you have velocity and acceleration and force. These are all, there are many vector quantities. What are scalar quantities? You can say speed is a scalar quantity, area is a scalar quantity, distance is a scalar quantity. Got it?
Yes,
Yes,
sir.
sir.
Yes. So age scalar, speed scalar, volume scalar, but acceleration a vector quantity. Okay.
Yes,
Yes,
sir.
sir.
Yeah. Which of the following statement about the motion of an object on which unbalanced force act is false? Which one can be a false? Unbalanced force, right? It can accelerate, it can slow down, it can change the direction, but it would continue. This one is false because if there is unbalanced force, it will change its speed. Okay.
Yes,
Yes,
sir.
sir.
And can you read the last one?
If a ball is thrown vertically upward in the air, which is the following statement about the motion of the ball is false. The ball will be traveling as fast as it was when it get back on the ground as it when first thrown up. The ball will be stationary for an instant at the highest point in its flight. The direction of the force of the ball changes, so the ball will fall back on the ground. The direction of the acceleration is always downward.
You know, the ball is thrown vertically upward in air. Which of the following statement is false? The ball will be traveling as fast as it was when it gets back to the ground, as it was when it was thrown upward. The ball will be stationary for an instant at the highest point. The direction of the force on ball changes, so the ball falls back. The direction of acceleration is always downward. This one is right or wrong? This one is
So
right.
it's
One of them is wrong. Okay, I will tell you how a ball. Let's say you are throwing a ball like this. Okay,
yes,
Yes,
sir.
sir.
so it will go upward, 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 upward. At one point in the sky, in it will become at rest for an
Yes, sir.
instant. Okay, and then it will start falling downward. Got it?
Okay, sir.
Yeah. But only wrong statement is the statement A. You know why?
No, sir.
Yes,
Because anything that falls, it falls due to gravity, right?
yes,
Yes,
sir.
sir.
Yes. And this gravity value, the acceleration due to gravity is 10 meter per second square. So it will always fall with this acceleration, this much acceleration. Okay. Always, any object you throw from sky at any height, it will fall with this rate. Okay. So this statement is wrong. All the other statements are correct. Okay.
Yes,
Yes,
sir.
sir.
Yeah, because see, you can throw it slower, you can throw it faster. At any speed you throw, the speed of coming down will always be same in every case. Okay?
Yes, sir.
Yeah. And after that, the next unit is called electricity. Okay.
Yes,
There are
sir.
some fuse devices, safety devices. Do you know what is a fuse?
In
Can you read only from here to here?
so I've seen it. Yes, I know it feels.
You know about a fuse?
Yes, sir. So I have it here.
What? Yes, please repeat.
So I have a fuse here.
Yes, sir.
I can't hear you clearly.
So I'm having a fuse. So let me check.
You are showing me a fuse.
So let me check if I have it here. Mm. So I don't have it here.
This is a fuse.
Inside resistors.
So this is a fuse.
There's a resistor.
Can you bring it in the camera? Can you keep it properly so that I can see? The background made you have applied a background. That black
Yes,
background
sir.
is blurring.
True.
So this is it.
Yes,
It's a
this is a
resistor.
fuse.
Huh.
This is a fuse or a
Is it?
transistor.
Says a resistor.
It is a resistor. It is not a fuse. Yeah, this is a fuse. That this like this thing in your hand. This is a fuse. Okay. Can you
Yes, sir.
take one out? Can you take one
Okay,
fuse
sir.
out? Yes. Now hold it in a way that you can see what is in middle of that. See what is in the middle of that.
Yes, sir.
What is there in the middle, in like in between that? There must be
Sir,
a thin wire, very thin.
yes, sir, there's a thin wire there. So there's a thin wire.
Please, sir.
Yes.
Sir, can I go to the restroom?
Yeah, sure. Uh, Adalberto, can you read this marked paragraph once? Then I will explain
Okay.
what is.
Mm, many plugs contain a fuse. The fuse is usually in the form of a cylinder or, or a cartridge, which contains a thin piece of wire made from a metal that has a low metal point. If there is too large a current in a circuit, the fuse wire becomes very hot and melts. The fuse blows. The circuit is now incomplete, so there is no current. There is no current. This prevents you getting a shock and reduce the possibility of an electric fire. Once the fault causes the increase in current has been corrected, the blown fuse must be replaced with a new one of the same size before the appliance can be used again. There are several sizes of fuse. The most common of the most thick appliances in the UK are 3 amperes, 5 amperes and 13 amperes. The correct fuse for a circuit is the one that allows the correct current but blows if the current is a little larger. If the current if a current in the circuit is 2 ampere, then it should be protected with a 3 ampere fuse. If the current if the correct current is 4 ampere, then a 5 ampere fuse should be used. It's possible to calculate the correct size of fuse for an appliance, but nowadays manufac manufac eh?
Manufacturers.
manufacturers manufacturers provide appliances already fitted with the correct size of fuse.
Now I'll explain you. See, many plugs, like plugs inside the devices, they contain fuse. Okay,
Yes, sir.
it is generally like this. You see, in form of a cylinder or in form of a cartridge, which contains a thin piece of wire made from metal that has low melting point. Okay,
Yes, sir.
yeah. Why low melting point? So that it can melt easily. It can melt
Easily.
easily. Okay, it blows. Fuse blows, or you can say it breaks. The wire breaks. You know why? Let's say this is my mobile. Okay,
Yes, sir.
now what I'm doing, let's say it runs on electricity. Okay, so if electricity level will increase, it can like the phone can blow, right? The phone can, you can say, like it might stop working due to over electricity, right? So there is a
Yes.
fuse in the beginning. That fuse will blow so that the current will stop reaching my mobile, and in this way my mobile will be safe from electricity. Yeah. So if the current
Okay,
is
sir.
more in the circuit, the fuse blows, breaking the circuit. If the circuit breaks, then the device is safe. That is in the like after the fuse. Okay.
Okay, sir.
Yeah. And after that, we have is Nakoma back? No.
No.
Can you read what do you see here?
Okay, sir. Person receive electricity shock when touch the metal casing. Broken heart element touches metal causes casing.
You know, when a electronic device is metallic, it can cause shock, right?
Yes, sir.
So that is why there is a earth wire. Have you seen a green wire, green colored
Yes, sir.
wire? There is an earth wire that prevents shock to the people who are using the appliance. Can you read this paragraph?
Yes, sir. Some modern appliances now use casing made from an insulator such as plastic rather than from metal. If all the electronic parts of an appliance are insulated in this way so that they cannot be touched by the users, the appliance is said to have double insulations. Appliances that have double insulations use a two-wire flex. There is no need for an head wire. Please, sir.
Got it? If the
Yes.
if the device is metallic, then you need a earth wire. But if it is not metallic, if it is having one more layer outside it of plastic to prevent, then you don't need a fuse wire. Okay.
Yes, sir. Please, I have a question.
Can you please repeat?
Sir, I have a question. I have a question.
Yeah, yeah. Ask the question.
So what is earth earth wire? Earth wire.
You know, there is an extra wire. There are two wires. One is called the phase wire, and one is called the mains wire. Yeah, and then in some devices, okay, you know, have you seen? If you open wire of any device, in some
Yes, sir.
devices there are two wires only, maybe one with the red color and one with the black color. But in some devices there are three wires, one with the red color, one with the black color, and one with the green color. This green colored wire is called the fuse wire. Okay, sorry, the earth wire. Okay,
Okay, sir.
yeah, and this earth wire is there to protect the person using the equipment by not by you can say by dumping the current so that the current doesn't reaches his body. Got it?
Yes, sir.
Yeah, just you can just remember like this that it prevents the person from getting shock by using the device. Okay.
Yes, sir.
Yeah, and after that we have these switches. Topic switches. What are switches?
So switches are so so I'm gonna explain
To
the question.
turn on or turn off the electricity, right?
Yes, sir.
Yeah, like there is a TV in front of you, so there is a switch. If you turn on the switch, current will start reaching the TV, otherwise it will not reach. So
Yes, sir.
switches are there in the circuit to stop or to turn on the flow of current. Okay.
Okay, sir.
Yeah. Can you read this statement? There is something very important here.
Yes, sir. Switches in main circuit should always be placed in live wire so that when the switches is open, no electric no electrical energy can reach an appliance. If the switches is placed in the natural wire, electrical energy can still enter a faulty appliance and could possibly cause an electric shock.
Yeah,
Mm.
like there are two wires, and the switch is always connected with one of the wires. So if that switch connects to the neutral wire, you can still get the shock. So you have to connect the switch to the other wire. This is what they are telling. See, when the switch is connected into the neutral wire, electricity can reach the faulty appliance even when the switch is open. the switch is not turned on, but still the person can get shocked. But if the switch is not in the neutral wire, but it is in the live wire, then the person is safe. Okay, there are two wires. These are like the older names, phase and mains. There are two wires. One is called the live wire, and the other one is called neutral wire. Okay, and then there is a wire called earth wire. Okay, yeah,
Yes,
these
sir.
are three main wires that you will see. And after that, you know what is power? Power is equal to current times the voltage. Yeah, can you see this? Power is measured in joules per second or watts. Watts or joule per second is the unit of power. Okay,
Okay, sir.
and what is the formula for power? The expression for power is current. That is I amperes times the volt. Okay,
Okay, sir.
yeah. Power,
Please,
you can remember by this triangle. This is
yes, sir.
P,
Please,
this is I.
Mm,
Note it down.
please,
Both
sir.
of you just note it down.
Please, sir. What is P?
Yes. What happened?
that's it. P is equals to I times
P is
No,
power.
sir.
This P represents power.
Yes, sir.
energy.
I represent
What?
I. And there is P,
I
I, and V.
represents current. I represents the current, the value of current. Okay. P power, I current, and V voltage. Volts. Okay.
Yes,
Voltage
sir.
Yes, sir.
units volt, current unit amperes or amps, or and power unit watts. Okay.
Yes,
Yes,
sir.
sir.
Yeah. Can you do these multiplication? Just remember the formula. Power is equal to current times volt.
Yes, sir.
If you want to find current, you can write it as I equal P over V. Or if you want to find V, you can write power over current. Got it?
Yes,
These
Yes,
are
sir.
the
sir.
three formulas that you will get from this relation.
Cancel.
You know what do you have to do? This is the volt value. This is the current value. Find the power by multiplying
Yes, sir.
volt and current. Okay.
Yes, sir. Mm. Please, sir.
Yeah. Hi.
Please, sir, can you give me 1 minute? Let me go to the restroom and come.
Yeah. Yeah. Sure. Okay. Nakoma, try to solve it. Power
Okay.
times power is equal to current times volt.
Please, sir.
Hello? Yeah. Yes, ma'am.
So what is W?
What is W? Where this W? This is unit of power. Power always will be written in W. W is watt, unit of power. Whenever you write power, either you write watt or you write joule per second.
Okay, sir.
Yeah, so they have written watt. You have to write watt.
Please, sir.
Yes, hi. Yes.
Please, am I supposed to solve the second one?
Yeah. I'm waiting for you to solve the second one also.
Okay, sir. So I'm
Yes,
done.
done.
Yes, sir.
What are you getting? What value are you getting?
So my first one, since you said to find power, it is
You know,
uh
this 230 is in volts. This is the
what?
voltage, and this is the current.
Yes, sir.
Yes. Sorry, this is the power. Kilowatt. Watt, kilowatt. Kilowatt means 1000 watts.
Yes, sir.
Yes, sir.
Kilowatt means 1000
1000.
watts. Power 1000 watt, and then 230 volt voltage. Now you have to find the current. So this will be 4.35.
Yes, sir.
4.35. That means you should use a 5 ampere fuse so that if the current is more than 5 ampere, the fuse will blow and your hair dryer will be safe. Okay.
Yes,
Yes,
sir.
sir.
Yeah. This is you just have to remember this formula for now, and after that, there is one more formula called energy is equal to power times time. Like power is flowing for how much interval of time, like for what interval of time, that will give you energy. Like if you say, sir, the power is 100 watts, and that is for a time period of 5 seconds, so it will become 500 watt. Energy, it will be 500. Got it? The formula
Yes, sir.
is E is equal to E times P. Or you can say power is equal to current times voltage. So energy will become current times voltage times time. This will give you energy. Now, can you solve these two questions for energy?
Yes, sir.
You can do it very quickly. Like you can,
Please, sir.
yes,
So
yes.
it's the same
Yeah, I
formula
can
as
hear you.
this E is equals to I times V times T. Is it the same formula as E is equals to P times T?
Yes, see, E is equal to P time T. I just told you, right? But you already
Yes, sir.
know P can be written as I times V. So P is I times V multiplied T. This is also E, right?
Yes, sir.
Yes. They are same formula. They are very same formula. Just highlight them. Make a note of the formulas. The previous formula, which was P is equal to V times I, and then this formula as well. These two formulas you have to make a note.
Okay, sir.
And after that, I will tell you about alternating current.
I'm not seeing the question. No, Grandpa, put it back. You're mad now.
Yeah, done?
Yes.
Yes. These were very easy. The units are joules, or if it is more than 1,000, you can write kilojoule. Okay.
Yes.
After that, there are two type of currents. One is called alternating current, or you can say AC, and the other one is called direct current or DC. Okay.
Yes,
Yes,
sir.
sir.
Yes. So this is your alternating current AC, and this is the direct current. There are two type of currents. Okay. And you know why they are
Okay, sir.
different? They are different because of the way they are produced. Do you know how current is produced? Why how electricity is produced?
Sir,
Mm-mm.
current is produced through sound waves.
Water.
Through water waves. There is a device called dynamo placed inside a turbine kind of thing. It's like a fan. When it moves, when it rotates, it generates electricity. So when electricity is generated by this device, it is of this form. It is of this AC form. Okay.
Yes, sir.
Yes. Just read this paragraph once, and it will tell you a lot. Read this paragraph quickly.
If you could see the current or voltage from the means, it will appear to be very strange. Its value increase and then decrease the value increase and then decrease and then does the same again but in the opposite direction. If you could draw these changes as a graph, they would look like a wave. This happens because of the way in which the electricity is generated at this power situation. See chapter 17. A current, a current of voltage that behaves like this is called an an alternative current. Alternating current. Alternative alternating voltage. This is a very different to the current and voltage we get from batteries and cells. Cells and batteries provide current and voltage that are always in the same direction and have the same value. This is called direct current or direct current or direct voltage. If you draw this as a graph, it will be a straight horizontal line. Figure 6.4 shows how the voltage of an AC supply com compares with the voltage of a DC direct current. Please sir, we can't hear you.
Okay, can you hear me now?
Yes
Yes,
sir.
sir.
Yeah. The current that is produced by cells or batteries, that is DC or direct current.
Yes
But the
sir.
current that is coming in your house right now through the wires, that is alternating current or AC. Okay.
Okay
Yes, sir.
sir.
Yes. And after that, we have some questions that you can. Okay, this is your homework. Can you note down? Can you
Okay
take a
sir.
screenshot if I zoom in?
Okay sir. So let me take a
Wait,
screenshot.
I'll do one thing. Let me take a screenshot and send. Now I'll just put in the Skype chat. Okay, you have to try to do
Okay.
after this class. Got it?
Yes sir.
Yes, sir.
I will also give you a YouTube video link so that after the class you can watch the video and understand everything. Okay?
Yes sir.
Yes, just one minute. Yes, I have sent you a link in the chat. Can you see it?
Sir, still come. Yes sir, I have seen it.
You have to watch this. Okay?
Okay sir.
To start like to understand everything in a better way, you have to watch it. Okay? And one video I'm sending you for fuse. I told you about fuse, right?
Yes sir.
Watch this video to understand fuse and earthing. Got it?
Yes
Yes,
sir.
sir.
Yes. There are two videos only that you have to watch. So please watch it, okay?
Okay sir.
So that when we meet in the next class, you come with you come prepared with everything, okay?
Okay
Yes,
sir.
sir.
And solve these questions. And now tell me if you have any doubts. Any questions? Any doubts?
Mm.
Yes, 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 sir. I have it down. I have it down.
Yes, yes.
Please, sir. Can I go back to vector and clan
Scalars and
scal?
vectors.
Yes, sir. Quantity.
I'll tell
Please, sir.
you. Let me tell you one thing. I told you difference between distance and speed. Do you remember that?
Yes sir.
Yes, sir.
What is distance?
Sir, distance is. So you said distance is like just walking straight.
No, that is
Displacement is just walking
Displacement.
straight.
Yes, sir.
Okay, wait. Let me show you something. Wait. Just watch it right now. Okay. There are
Yes, sir.
some references in it to make you understand better. Open the link in the chat that I have sent. Watch it right now and let me know. Watch it
Okay, sir.
quickly. Yeah.